In note 6.5, example 3, we learn how to graph general tangent functions. So we can use similar logic as we did when we learned to graph general sine and cosine functions. So our goal is going to be to graph something of the form y equals a times tangent bx minus c plus d. We're not going to do as many transformations as we did with sine and cosine, so we're going to make it a little bit simpler. And we're not going to graph functions that have both horizontal dilations and horizontal shifts, so at the same time. So we'll either change the period with the dilation, or we'll have a horizontal shift, but not both. When we graph general tangent functions and cotangent, when we learn that next, we'll begin by determining the asymptotes. And once we do that, then we'll determine a few points on the graph. And the way that we're going to find that is we will transform a few key points from the parent function. And the most useful ones are negative pi over 4, negative 1, 0, 0, and pi over 4, 1. We highlighted those in the previous example. And once we transform those points and we have the vertical asymptotes, we will be able to graph a general tangent function pretty easily. So let's talk a little bit about how we find the asymptotes. So we know that in the base period of tangent, we have asymptotes at plus or minus pi over 2. In the analysis we did before, we said that we had vertical asymptotes at x equals pi over 2 plus pi n, but for now we're just going to focus on the base period, the base cycle that goes through the origin. So now instead of having our argument just x inside the tangent function, we have bx minus c. So we're going to have vertical asymptotes whenever bx minus c equals negative pi over 2 and pi over 2. And if we solve these equations for x, for our given function, we will get the equations for the vertical asymptotes in our specific tangent function around that base period. Then in terms of the period, just like we did with sine and cosine, the new period is going to be pi over b. And another way to think of the period is it's the distance between the asymptotes. Remember, for sine and cosine, we said the period was 2 pi over b because the period for the parent function is 2 pi. So let's go ahead and graph a tangent function. In example 3a, we're going to graph y equals tangent x over 4 plus 1. So the first thing in our process is let's find the vertical asymptotes. So now instead of having x alone inside the tangent function, we have x over 4. So we can solve the equation, when is x over 4 equal plus or minus pi over 2, because the vertical asymptotes occur at plus or minus pi over 2 in the parent function. So to solve this, I'll multiply both sides of the equation by 4. So I'll get x equals plus or minus 4 pi over 2, which is plus or minus 2 pi. The period is the distance between the asymptotes, or it's also pi over b. B in this function, this is actually 1/4. This is like 1/4 x inside the tangent function. So pi divided by 1/4 is pi times 4, which is 4 pi. Or the distance between the vertical asymptotes would be from negative 2 pi to 2 pi, which would also be a period of 2 pi. In order to graph this, the first thing we want to do is graph the asymptotes, but we need a scale. So just like with sine and cosine, the interval for key points is going to be every 1/4 period. So that's going to be 1/4 times 4 pi, which is pi. So I would want to set up my x-axis scale in terms of pi. So I'm going to do 2 units is pi. So pi, 2 pi, 3 pi, 4 pi. I'm going to set up my scale. And then negative pi, negative 2 pi, negative 3 pi, negative 4 pi. And on the y-axis, I'll let 2 squares be 1 unit. Okay, and now we can go ahead and graph our vertical asymptotes at positive 2 pi. So x equals 2 pi. And another one at x equals negative 2 pi. And the next vertical asymptote will be a full period over. So if we go from 2 pi, the period is 4 pi, so 2 pi plus 4 pi is 6 pi. So we will have another vertical asymptote at x equals 6 pi. Okay, now we need a few key points so that we can sketch tangent a little more accurately. So the key points that we're going to transform for tangent are negative pi over 4, negative 1, 0, 0, and pi over 4, 1. For sine and cosine, we only needed to transform a 1 point. And then let's see what's happening to our x values and our y values in our function. So our x values, because we have this x over 4, are getting multiplied by 4. So x values are being multiplied by 4. And the only thing that's happening to y values is they're being, 1 is being added to y values because of this plus 1 here. So I'm going to apply these transformations to these 3 key points. So x values are multiplied by 4, so this becomes negative pi, and I'll do the same thing to all 3 points. 0 times 4 is still 0. Pi over 4 times 4 is pi. And then we'll transform the y coordinate, which means we're going to add 1. So negative 1 plus 1 is 0. 0 plus 1 is 1. And then 1 plus 1 is 2. So these will be our points in our base period. And so now we'll go ahead and plot those. So we've got negative pi 0, 0, 1, and pi 2. And we know in general what a tangent function looks like. So we can sketch this function in the base period, and then we can copy this over to the next cycle. So I'm going to copy that over into this cycle. And if we want to, we can copy half the cycle over into the next one as well. So at negative 4 pi, it'll be 1, and negative 3 pi, it'll be 2. And I can sketch this going up, and then I'll include an arrow because it continues on.